Hi class, Mr. Watlington, how you doing today? Welcome to week 4. We're in workshop 4. Man, this class is really zipping right on by. So what are we going to cover today? This is just going to be a broad tutorial on virtualization and cloud computing. You know, that is kind of the hot thing today, right? Virtualization, you may have VMware or some other tool running on your system at home, as well as the cloud. The cloud. What is the cloud? All right, let's talk about this. Let's get into virtualization. Now, when we think virtualization, really we're going to go back to something we covered, I think it was in workshop 1. If you remember this diagram, it was this basic computer design, right? We broke your basic computer into basically three layers. Your computer hardware, computer operating system, and applications. You know, our hardware was our CPU, our storage, memory, all of those pieces of those hardware pieces of your computer. Then on top of that hardware, we installed an operating system. That operating system could be Windows 10, Windows 7, Windows 8, whatever. It could be a Mac operating system if you have a Mac computer. Or for a few different other applications, you may be a Linux guy, so you may be running Ubuntu or some other type of operating system. Doesn't really matter. But that operating system, it installs directly on top of the hardware. Then on top of the hardware, what did? We added applications. Now these user applications, things like Word, Excel, PowerPoint, whatever application, or your games if you're a gamer, all of those things loaded around here. And then of course us, the user, we interface with the applications that interface with the operating system that interfaces with the hardware. Now that's our basic computer model, and we see that model and it's tightly coupled. What do we mean by that? That all of these layers are tightly coupled together. So that's what I say. So here's just a better breakdown of that, of your different components, your CPU, memory, storage, all of these pieces, and on up the stack like we just talked about. Here again, tightly coupled. All of those, that operating system is sitting directly or on top of that hardware, and the applications sitting directly on top of that operating system. Everything is tightly combined together. Benefits? Well, just that. Everything is together. Some of the cons to that is many times when we're using our computers, we are not really using all of the CPU processing power. We're really not efficiently using all the memory or the storage. So you've got capacity there that actually your computer could be doing more things than what it is. So that is kind of one of the cons. So that's what virtualization really helps us do. So when we think about virtualization, we're going to talk about two types of virtualization: Hostit and bare metal. This first type is we call hosted. This is the kind that you have typically on your home computer, where you're virtualizing on that type of device. So how do we start out with virtualization? As you see, it's the exact same as we started out with our traditional computer. We have hardware. We have CPUs, memory, storage, network interface card, your NIC, as well as your different input-output ports, or your I/O ports. Then, if you look, the second layer is basically the same. You have an operating system. Let's say your home computer is a Mac. You may have Mac OS running. Or if you're a Windows guy, you may have Windows 10 running as well. Now, on top of that, that's where you have your host applications. So far, right? So far, everything looks the same as a normal computer. Here's where the difference comes in. Now, what we install is a piece of software that we call a virtual machine monitor or a hypervisor. You may hear it called hypervisor, especially if you're using VirtualBox or VMware, one of those tools. If you're a Windows user, that virtual machine monitor sometimes is built right into your Windows 10 or your Windows 16 server applications. All right, so we put this piece of software right here. What does that piece of software do for us? Well, it does a lot of things, because this is what we call our abstracted layer. Now, like we said before, all of these devices have extra capacity most of the time. So what this hypervisor does, it will go in and it will allocate a portion of like your CPU processing It'll allocate a portion of your memory, also to allocate some space on your hard drive, and it will also do a very similar thing with your network interface card, where it'll allocate the usage of that, and it will also direct the input-output ports. So that way, all of these things, guess what it looks like to this hypervisor? It looks like hardware. Yes. So once I do this, I've got the actual hardware at this layer, but since this hypervisor, this piece of software, now it says that I'm going to use maybe a portion of your CPU processing power. We're going to allocate, let's say if you had 16 gigabits of RAM in your computer. It said you can set it to where, okay, I'm going to allocate 4 gig of RAM to operate as virtual hardware right there. Likewise, it'll take some space on this drive, let's say 20 gig. You may have a, I don't know, a 2 terabyte, 1 terabyte hard drive. And you can take 20, 40, 60 gig of that. And it says, what? I'm going to allocate that space to this virtual machine software, where it's going to appear as hardware. What it also does, like I say, in most home computers, you only have one network interface card. But what it will do, it will put it into a mode of where it will virtually use that card. So basically, it will set up its own little network to where now this software will recognize this card as a means of a network interface. It will do similar things with your I/O ports, like your keyboard, your mouse, your monitor. It will also say, hey, look, I am going to share operating time with these. So now what you've got, you have your actual hardware at this level, but then you have these pieces that you've allocated is now sitting right here. So it's sitting here, or it's not physically sitting there, but it is being allocated to this piece of software. So it's called your hypervisor. Why do you want to do that? Because now I can load another operating system right here. Because these operating systems, or any operating system, it's looking for certain things for it to operate, right? It's looking for a CPU, it's looking for memory, it's looking for a hard storage space, and you don't really need a network card, but it's very handy to have network access, and it's looking for I/O ports. This operating system right here, my host operating system, is sitting here and it's using that. Now I have what I call guest operating systems. It thinks that it has hardware because this piece of software, this hypervisor, have allocated portions of the actual hardware to these. So now it appears I have 3 operating systems running on the same machine. I've got my host operating system, which is Windows 10, and now I have 2 guest operating systems. In this example, I've got Ubuntu, and I have Windows 7 running at the same time. Now that I got an operating system, just like I can with any other computer, now I can put guest applications. I can have with my Ubuntu applications running here. I can have my old school games running here on my Windows 7 for you old school gamers, you know. You want to play Galactica or something. So now you can run that right there on that old Windows 7 box. So now you see I've got host. I have a host operating system, and I have my host applications. I have a guest operating systems, and I have guest applications. That is what we call virtualization. This is called hosted virtualization. And this is what we call having an abstracted layer. So this hypervisor abstracts or separates part of your hardware infrastructure so that it can now host more operating systems. All right, let's take a look at the second type, okay? This is the one we call bare metal. Now, in a bare metal environment, this is typically what you're going to see with servers in a server environment. Everything looks the same except for one critical piece is missing, okay? If you look, we've got hardware, and typically in a server environment, you're going to have a lot more hardware, a lot more robust hardware. You're going to have more CPUs, many times multi-core CPUs, 1, 2, 4, 8, up to 16, even 32 cores. I mean, high-end processors, and a lot more RAM, a lot more memory here. You can probably have maybe the terabytes of RAM, a lot more storage, in a typical server, and typically you're going to have multiple network interface cards, as well as your I/O devices. Now, so that is your same type of hardware. Now, what you see is missing operating system. You may say, how is this going to work without an operating system? Well, now the applications like your hypervisor that's used in a server environment, it has its own kernel or its own part of the operating system built in. So I don't really have to load a host operating system here. It's a VMware, like if you may hear this term EXSI. That is the server version of a hypervisor that VMware produces. So that is right there built into the hypervisor. Likewise, if you say you're running server Windows 2016, again, it has a virtual machine monitor built right into that server software. Okay, so now that I'm able to do that, now I can do the same thing. I can have multiple Windows servers running. I can have multiple Red Hat servers running. And this is a typical layout you would typically see in a server environment. So if you're looking at like a data center. Now, years ago, when we first started doing data centers, you would have actually a separate box, a separate server for every one of these, right? Whether it was an application server or a web server, or email server, or print server, each of these used to be a separate box. So if you think about that, if you went to a data center, now you had racks and racks and racks with server after server after server that took up lots and lots and lots of space. Lots of cooling required, lots of power required. Now we can have one single box that's able to run multiple servers at the same time. So you can imagine that drew down the footprint of a data center quite a bit. Okay. Well, actually, the footprint of the data center didn't really draw down. What it did help, though, is now I can host tons more servers. I can have backup servers, and I can have all these other things in that same data center. And I don't need it to replicate as much cooling and environmental control systems. So virtualization has saved us quite a bit of money, but so the way we do virtualization. So that is how we do host level virtualization and bare metal virtualization. One other type of virtualization we're going to talk about is, and we call it containers, but really it's application virtualization. Application virtualization. Okay, as you're going to see, we start out the same, right? We have our hardware. You see, that hardware layer, I mean, it's got to be there because you got to have something to load your operating system on. And very similarly, we can put an operating system. We can have host applications. Here again, here's where things change. Now we have what we'll call a container. If you've ever heard this thing, a company called Docker. They've gotten very famous in the last probably 5 to 7 years because they are a container engine. Now, what this is, and it may say, well, wait a minute, that looks just like the VMware that we saw earlier. It's similar, but I'll walk you through some of the differences. Now, within this container, it has what we call a minimal guest operating system, meaning that it may have a Linux core or a Linux kernel sitting right here in this container, and it has all the binary and library files that you need to be able to run applications. And this whole thing, this whole container is self-contained, meaning this is all just one, almost like its own application. And you can pick this up, move it somewhere else. You can have it on a thumb drive, plug it in, and it will run on basically any operating system. It doesn't matter because it is not linked to this operating system or to the hardware directly. Everything it needs to run is inside of that container. One of the good things about doing containers is, from a security perspective, when this container, if let's say if I need to make updates, well, with the company that builds these containers, what they do, they throw the whole container away and send and publish a new container. So it's not like I have to go in here and run antivirus and all these other things inside this container. Everything is in there is self-contained. But that's called application virtualization. All right. Questions on that? Didn't hear anything, so I guess not. You must have got it. I tell you what, now let's switch gears. Let's talk about cloud computing. Cloud computing. Now that's a lot, it's a pretty famous word now in the cloud. Everything's just move it to the cloud, right? So what is this this cloud? What are we talking about? Cloud. This ubiquitous word. Well, first let's talk about some of the benefits. Why do we want to do cloud? Well, what the cloud does for us, it's allows us to have access anywhere, anytime, as long as we have an internet connection. And it's very flexible, from resources perspective. I can get as much as I want, services wise, or I can get as little as I want. Rapid provisioning. And what this means is that they can build you up services and get it to you quickly. Whereas before you had to sit maybe and build your own server or install your own applications and be sure that application is set up and running right. Well, in the cloud environment, a cloud provider is able to get that to you really quickly. And it does lower the total cost of operations. What does that mean? I paid for just what I need. You ever had, like, let's say Amazon using, or Google, their Google Drive. They have a free version, Yeah, totally free. You get, 100 gig or something like that. And if that meets your needs, you are good to go. If you need more storage space, you pay for the next level up. If you need more than that, you pay for the next level up from that. So what it means is pay as you go. You only pay for what you need or what you use. So when we think about this thing called cloud, it is cloud, a metaphor for what we call the internet. And that came from years ago when we first started talking about this thing called the internet. Just trying to on a schematic or a diagram, trying to draw a bunch of servers and routers and switches got to be painstaking. So what did we do? We just drew up this thing called a cloud. Just put a cloud around that, and everything in that cloud, then everyone kind of knew what we were talking about. So that was some of the first vernacular of the internet, of how we would portray that and from a graphical perspective. And it kind of caught on, so it just kind of goes into this cloud. Don't worry about what's in the cloud. We got other smart people behind the curtains who knows what's in the cloud. All you just need to know how to do is how to hook up to the cloud. So that's kind of the definition. Now, if you want the National Institute of Standards and Technology, the NIST definition, for you guys who just, wait a minute, I need a nice scientific definition. Well, here it is. I'm going to give it to you. All right? Cloud, a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, such as network, server, storage, applications, and services that can be rapidly provisioned and released with minimal management, effort, or service provider interaction. Whew. Give me a minute. That was a mouthful. Do you know what that means? I don't. I teach this, and man, that is just some confusing jargon, isn't it? So let's kind of forget that definition, okay? Can we just kind of forget that? Here's my definition. Cloud. It's a really cool service delivery model. That's really what the cloud is about, is how to deliver services. In this COVID-19 environment, right? A lot of restaurants had to relook at their service delivery model. Okay, here's what I mean. You had a lot of, we've always had fast food restaurants that had drive-through windows, and boom, here you go, 2 minutes, we get you out of the window or whatever. But a lot of your traditional, family-style restaurants, they weren't. No, we don't do drive-throughs, and some of them didn't really do takeout. They were designed for you to come in and sit down and enjoy a meal. COVID-19, kind of changed that. So now you had these restaurants having to rethink on the fly their service delivery model. Now they had to come up with ways of, wow, I need to get food out to you. So and that's where you had Uber and Uber Eats and all these other small startup companies that's making a killing. Okay, well, hey, we will deliver the food to the customer for you. So that's what that happened. They changed their service delivery model. That's what cloud computing does for us. Is there technology associated? Of course there is. However, the big takeaway is now how can we deliver services to you in a different way? So when we talk about services, let's think about three things, right? Three things from a service delivery model perspective. And we call this the SPI model. SPI for software as a service, platform as a service, and infrastructure as a service. Software as a service, SaaS, if you've ever seen that, that's what that means. Platform as a service, infrastructure as a service. Now, what are we talking about when we say this, okay? Let's look at each one. Okay, so when we think about, and I'm going to start at the bottom. Now, let's keep in mind what we just talked about with your basic computer model, where you had hardware, relate hardware to infrastructure. You had an operating system. Think about the operating system as a platform. And you had applications. Think about applications as software, okay? If you can make that correlation in your mind, this will make this whole analogy much, much, much easier. Okay, so we got hardware, infrastructure, operating system as your platform, and applications as software. So now, how do I get these as a service? Because if I got my own computer, you mean I've got to buy the hardware, right? Yes. Then, if I got my own computer, I have to buy an operating system. And if I have my own computer, I've got to go out and buy and own and configure my own applications and keep them up to date and everything else. What the cloud does for us is, hey, look, I'm a company called Amazon Web Services or Rackspace, and there's multiple others, AT&T, that provide infrastructure as a service. And what they're saying is that you don't even need hardware. Here's what we'll do. We will provide you computing power, meaning that if you can connect, if you have the ability and the bandwidth to connect back to our site, you can send your stuff to us and it will process on our processor. So you don't have to own that. That's infrastructure as a service. Now, what is platform as a service? Here again, think about it as an operating system. Meaning that I want to be able to have some type of operating system, but I don't want to own it. I don't want to buy Windows. So what did Windows do for you? Think about it. Microsoft, they got into this game. They said, okay, you can buy Windows 365, okay, with a subscription, just pay monthly. And we will give you Azure, Windows Azure, which is basically a platform as a service. Meaning that you don't need to own Windows. You can operate right here off of our website and do the things you need to do. And there are other, Google. Actually, Google does the same thing. It has that same type of app engine that does it. Now, I would say probably one of the biggest examples of people who use platform as a service are gamers or gaming developers. Okay, if you're a gamer, if you develop and write games. Well, you want to publish, you want that game to work on different platforms, such as maybe an Android phone or an Apple iPhone. Well, to do that, you have to have their software development kit to develop on. Well, you don't want to own that, right? No. So that's why companies like Android, Google, and they will provide you that platform for you to develop your game on, and then you can launch it with them as well. But you don't want to own it. Now, you may have to pay a subscription depending on what services you want. There's usually, most of these, there's a free, entry-level version that's free, but it doesn't give you all of the different bells and whistles. So that's how they suck you into paying the $19.99 a month. Oh, well, you need this version if you want to do this, 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 and this. All right, so that's those two layers. Now, this is the one that most of us probably use the most, software as a service. Software as a service. And what that means is I don't want to have to own applications. I just want to be able to go out and have it available, like Gmail, okay? When you have Gmail, and most of us have Gmail now, right? What do you own with respect to that? Nothing. You don't have to load anything to your computer. You don't have to, like if you had Outlook, you'd have to load Outlook, but really not even with Outlook anymore. Why? because Office 365. Now you can get Microsoft Outlook as a service. It doesn't even have to be loaded on your computer. Really, you don't even have to have a mail client, M-A-I-L, not M-A-L-E. Okay, there we go. A mail email client loaded on your computer anymore, because most all your email now is as a service, is software as a service. So there's lots of things. You can go to, like I say, Google. They've got what, Google Docs. And now you can get a word processing, you can get spreadsheet, you can also get presentation software, all of these things as a service where you don't own it. So that's what cloud really is how you, a different way of providing services. It's a different way of providing infrastructure, it's a different way of providing platforms, it's a different way of providing applications. So now that we know the services, now we got to look at how do we deliver these services. How do we deploy them? Okay, there's 4 different cloud deployment models. Well, first we have what we call a private cloud. And what is a private cloud? That's like the cloud that I've got in my home, right? You can go down to Best Buy or anywhere, and you can buy a external hard drive that have cloud capabilities. So that way you can set that thing up, connect it to your home computer, and you can get to your files from anywhere you have internet access. That is a private cloud. Most businesses, companies, they run their internal private cloud. One of the good things about a private cloud, many times, it can increase security. Maybe. We'll talk about that a little bit. But yeah, now let's look at a public cloud. Public cloud, that's like Google, okay? Your Google, Gmail, and Facebook, and excuse me, all of these different things that we use today, all these different services, those are public clouds, meaning that they are open to the general public. Anybody can get a Gmail account, pretty much. Good thing about these, reduced costs. Bad thing, or I would say a con, not so much a bad thing, you're gonna get what you're gonna get. So if you don't really have the ability to do a lot of tailoring, I want to change this to look like this and that to look like this. In your own private cloud, you can set it up any way you want. Here, you're gonna get what you kind of get. Then we have what we call community clouds. And what a community cloud is just like it sounds. That's when we have a lot, some type of industry. I always like to use the example of hospitals. Here I live in Dallas area, so here in the Dallas area, there's a lot of hospitals, a lot of medical industry here. So many times, these hospitals, they are all connected via a cloud that they share within themselves. So that way they're able to share medical data and other information within their own community. It's like a community cloud for specific customers. Me, I could not join that because I'm not part of that community. But that's what that is. And the last one really is called hybrid. What a hybrid is really a combination of any or all of these 3. And this is what you really see, especially in industry and at home many times, is that hybrid cloud model. Okay, so let's take a look at cloud components. What makes up the cloud? Okay, let's take a look at that. Really, it's pretty simple. It really is pretty simple. Really, it's only 3 components. Starts off with, you got to have some type of client. And that client could be a thick, thin, or a mobile client. When we're talking about a thick client would be like your desktop computer at home, okay? Or of that type, a thick client, meaning that it's got its own operating system and it's got everything else, and it also has a connection to the internet where you can get to that. A thin client, something like an iPad, right? That would be, we would consider a thin client. It's not as robust as your home computer, but here again, as long as it can connect to the internet, you have access to cloud services, all the way down to mobile clients, which now like your phones and those type of personal devices. It's here again, if they can connect to the internet, they can get you to cloud services. Now, the second part is data centers. Now, this is where we actually host applications and all the different things, all the infrastructure, or the platforms, the services. This is where they're all hosted at, is within this data center. And the third part of this is what we call our distributed servers. And what these are servers that are distributed, many times geographically or within a functional area to be able to do what? Provide services. Because many times that you may have 1 or 2 of these, you may have 50, 60 of these to be able to satisfy all your different clients. And the other thing you will need, of course, is the internet, because this is all built on having access from your clients via the internet to the distributed server. So basically, what happens if you want to get to, like I say, Gmail, right? You want to get to your Gmail account. Well, on your device, let's say you could be on your phone, mobile device. What happens? You go there from the internet, it goes to this distributed server. And what this distributed server does then is it actually adjudicates the process of now going back to the data center and said, hey, I want to pull up Larry Wallington's Gmail account. And it pulls it, and that distributed server then sends it back. So that's how the cloud process kind of works. So as you see, it's not overly complicated. Now, I will tell you, I'm talking at the 50,000 foot level. You get down here and you want to be a cloud server technician or a cloud storage data center technician. Yes, there's a lot of things you need to know. Then that's when it starts to become more complex. But overall, how the picture works, I really want to demystify this thing we call cloud. All right. So when we think about cloud, one of the things that everybody brings up, what about security? What about security? We want to be secure. Of course you want to be secure. And this is how the cloud can help. Here's some of the advantages of cloud provided security. First of all, immediate deployment of security patches. Now what I'm saying is if you're with a reputable cloud provider, they do that. That's their job. They do it for a living. And they have very good technicians and specialists and technologists who ensure that patches and everything is deployed as quickly as possible. If you're doing this at home, you may not hit that little button and say, "Oh, I got updates." Oh, I'll get to it when I finish my homework assignment. Right now, I got too much stuff to do, and this little update button keeps popping up. So you're probably not updating your computer as meticulously as you probably want to. Also, a large cloud provider, they have a large amount of hardware and software redundancy. So they've got data centers and racks and racks and racks. So if your desktop in the cloud, if the server it's on goes down, it will automatically shift over to, and they have it already replicated multiple times, so the odds of you losing data in the cloud is pretty minimal with a reputable cloud provider because of that. Incident response timing, they're on it that quick. And better utilization of a lot of their controls, a lot of their security controls they have in place, because here again, they have very good, very sharp cybersecurity technicians that are providing that. Here are some of the disadvantages. You may say, well, wait a minute. Let's just go hog wild and over cloud because it's meeting everything. However, there are some disadvantages with being in the cloud. One is if there is some type of incident with cloud, country and jurisdiction issues. That's the issue. Because someone in China, because we're talking about the internet, right? And the internet has no physical or geographical boundaries. So someone could be sitting in China or Pakistan or wherever, and if they run some type of exploit, now how do you handle that from a legal perspective, right? So that's just kind of one of those issues. What we call multi-tenant risk. Yes. Why? Because in that data center, I've got my information, you've got your information, and millions of other people have their information all sitting there, relatively close together. So if something happens that a bad guy gets in, now they can skip and hop from your information to mine to other people. Malicious insider. So what happens when that guy who works at Google, for whatever reason, doesn't like his supervisor anymore, and he wants to become an insider threat? Well, he can do some great damage. Great damage. Another one that we have to think about from a business, this is really from a business perspective, vendor lock-in. Meaning that, okay, once you've moved all your stuff to the cloud, especially if it's not a reputable cloud, you went for the lowest bidder, right? And so many times we get what we pay for. So now you've got all your information on this cloud provider. And especially if you don't read the contracts carefully, and you want to move your data at some point to another. Well, the problem you may run into is that they have formatted your data in a format that is not compatible with other cloud providers. and that's not a good thing. So you're kind of locked into that vendor. And there's always that risk of the cloud-based provider failing. Well, if you're with a reputable one, that's probably not going to happen. But if you're with some smaller cloud providers, then yeah, that you run that risk. And then if it fails, and then you go back to here. Well, I want to get my data back. Well, depending on what type of contract you wrote, you may not be able to get your own data back. Or if you do get it back, it could be encrypted. And they've gone out of business, and now you have no way of unencrypting or de-encrypting your own data, so you're kind of stuck there. So there are some things, and really some of these are from a more of a business perspective than a general home user perspective when it comes to cloud. Okay? All right, guys, thank you. We've talked about today virtualization, Hostit, bare metal, as well as application virtualization, and then we took a pretty high-level view of looking at cloud and cloud computing from a service delivery model perspective, looking at it from providing software as a service, a platform as a service, or infrastructure as a service. All right, I hope this helped you out a little bit with cloud virtualization. Have a great week. Have any questions, please contact us. Take care.